Good evening, children.
Good evening, ma'am.
Good evening, ma'am. Good evening, ma'am.
Good evening, ma'am.
Good evening. Good evening, children. Good evening.
Ma'am, good evening, ma'am.
Good evening, Raja. Good evening.
Ma'am, I'm not in my home. I'm in my mom's office.
You are in your?
Mother's office, ma'am.
Okay.
So I thought I will be back to home before the class, but
Okay. So,
I'm not.
what is your
So,
inconvenience? I don't understand.
so I am not having my note, etc.
Oh, okay. Okay. Fine. 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 So, you just want to
I thought
listen
I
to
will be back.
us. Okay. Okay.
I thought I'll be back, but my
No problem.
mom got.
Fine. Fine. Make sure that you write out the contents in your notebook later. All right.
Yes, ma'am.
Okay. All right, children. Yeah, I think we have finished up to the fourth one in this, right?
Yes, ma'am. Yes,
Yeah.
ma'am.
Yeah,
Yes,
children.
ma'am.
Yes, children. Please try the fifth one. Let's complete 5, 6, 7, 8, and then go back to the other concepts in exponents.
Okay, ma'am.
Yeah. Just get back in a minute, children. Please try. Finish 5, 6, 7, and 8, and we'll discuss the answers. Write down the question and then work it out. Done, children?
Ma'am, done for fifth and sixth sum, ma'am.
Ma'am, I'm almost going to finish sixth one, ma'am.
Okay, fine. Does it take this long, children? Fine. I'm right here, completed. Okay, then we'll do one thing. Finish 5 and 6. We'll see the answer and then you can do 7 and 8.
Yes, ma'am.
Yeah.
Completed, ma'am.
All right. Let's see the answer for the fifth one. What is the answer?
Yes,
What is
ma'am.
X for the fifth one?
Ma'am, 1/25, ma'am.
1
by 5.
minus 1, ma'am.
1 by 1. Danya said 1 by 25. Huh?
Yes, ma'am.
The value of X is 1 by 25, right?
Yes, ma'am.
Ma'am, I also got the same answer, ma'am. 25 to the power minus 1.
Okay, fine. Others? Devadarshini, Kirtana, Sindhu, Sanjay, Raja, what are your answers?
Yes, ma'am. The same, ma'am. 1 by
Same.
20.
1 by 25. So what the first step? X is equal to, the power is negative, so we need to make it positive. So we take the reciprocal of the base and negative of the power. Divided by 1 by 4. The whole square. See, you can work it in different ways, children. I'm just doing one of it. So now what happens? The powers are the same. The bases are different. The bases are different. The powers are the same. So you can, and it's division. So divide the bases. 5 by 4 divided by 1 by 4 and raise it to the same power 2. The rule is a to the power m divided by b to the power m. Bases are different. It's division, but the powers are the same. Is equal to a divided by b, the whole raised to m. You can relate it here. 5 by 4, 1 by 4. Division. Bases are different, but the powers are the same. 2, 2. So it's 5 by 4 divided by 1 by 4, the whole square. X is equal to 5 by 4. In the bracket, it becomes into 4 by 1, the whole square. So 4 gets cancelled. The value of X is equal to 25. 5 square 25. The value of X is 25. So X to the power, I'm getting 25, children. I thought you people said 1 by 25.
Ma'am, x is 25, ma'am, but minus x is 1 by 25, ma'am.
X to the power minus 1 is 1 by 25, ma'am.
Okay, no, I had actually asked the value of X only, not, okay, fine. Fine, then you're all right. So X is equal to 25. X to the power minus 1 means 25 to the power minus 1, which is nothing but 1 by 25. Very good. Very good. See, you can do this in different ways. Children, this is one of the ways. See another way of working this. See another way of working this. What you can do is you can write 4 by 5 the whole power minus 2 as it is. Okay. And then we know that if division becomes multiplication, we need to write the reciprocal of the next term. Like say we write this one as it is, 4 by 5 the whole power minus 2 as it is. Now this division, we want to make this multiplication. So multiplication. Then we need to write the reciprocal of this one. To write the reciprocal of this one, what we do is we make 2 minus 2. And we write the base as it is, 1 by 4 as it is. Reciprocal means change only one, either the base or the power. So now the same rule, a to the power m into b to the power m is equal to a into b the whole power m. So this is going to be 4 by 5 into 1 by 4, the whole power minus 2. 4 gets cancelled. So we have 1 by 5, the whole power minus 2, which is nothing but reciprocal of the base, negative of the power. To write equivalent is equal to 25. So the value of x is 25. And again, x to the power minus 1 is 25 to the power minus 1, which is 1 by 25. You can do it in different ways. What you see here is again different. Here I have written the equivalent. I have written the equivalent of this one. And here also, I've made division multiplication. Here I've written the equivalent. Division becomes multiplication. So reciprocal of this one. While writing the reciprocal of this, I did not change the power. I wrote 2 as it is. I wrote 1 by 4 as 4 by 1. Then the rule. Base are different, multiplication, same power. So 5 by 4 into 4, the whole square. 4 gets cancelled. X is 25. So it's 1 by 25. Yes, what's the answer for this one, children?
19 by 64.
64.
19 by 64.
Yes, ma'am.
Very good. 19 by 64 is correct. All right, let's do the next one. Yes, what this, children? Yes, children, what's the answer for this one? If you bring a to the power minus 1 to the denominator, it will become a to the power 1. If you take up 2 to the power minus 4 is the denominator. When you take it up to the numerator, it becomes 2 to the power 4 into 5 cubed. Into 5 cubed. So this is 16 into 125 divided by 8. 8 ones are 8 twos are. So it's 250. When 8 to the power minus 1 comes down to the denominator, it becomes 8 to the power 1. When you take up 2 to the power minus 4, but that is when a quantity is in the numerator and you bring it to the denominator, write the opposite sign in the power. Write the negative of the power. When a term or when a particular term travels from the numerator to the denominator or from the denominator to the numerator, write it with the negative of the power. So that's what it is. So a to the power minus 1 comes down to the denominator as a to the power plus 1. 2 to the power minus 4 from the denominator goes to the numerator as 2 to the power plus 4. And that 5 cubed which is already there. So this is 16 into 125 divided by 8. 2 into 2 to the power 4 is 16. 8 ones are 8 twos are 250. Okay, I've used the law of exponents here. You can also do this. Same answer. I've written 8 as 2 to the power 4. See, first, as I told you, bring this up to the numerator and this to the denominator. That's the first step. 8 to the power 1 comes down, 2 to the power 4 goes up. Then I've written 8 as 2 cubed. Then I've used the law of exponents. Base are same, it's division, so subtract the powers. Subtract the powers. So there's nothing but 2 into 125, which is 250. Either base is fine. Excuse me. The next one. Yes, what's the answer? Yeah. What's the answer, children?
I'm doing, ma'am.
All right, all right.
Ma'am, can I tell the answer?
Yeah, what is it?
60 by 47, ma'am.
So you're getting 60 by 47. Let's see. Okay. Others completed.
Ma'am, completed, ma'am.
Yeah, what's your answer?
60 by 23, ma'am.
60 by 23. Okay.
Ma'am, I too got 60 by 23, ma'am.
Sindhu, is it?
Yes, ma'am.
All right, 60 by 23. Fine. Others?
Ma'am, actually, I added 5 power minus 1 instead of subtracting, ma'am. That's why I got a wrong answer.
Okay, okay. Do the correction. No, fine.
Yes, ma'am.
Sixty by 47 is right. Oh, even I have added, huh? Oh my God. Okay, even I have added. So this should be 20. 60 is the LCM. 20 plus 15 minus 12. 35 minus 12. 23. 20.
Yes.
Yeah, I've done the same mistake like Madhumita. Okay, so 60 by 23, children, or 23 2 times 46, 14 by 23, correct?
Yes, ma'am.
Yes, ma'am.
All right, children. Okay, let's continue with the chapter. We finished this, right, children?
Yes, ma'am.
Yes.
Ma'am.
Okay. So this is the next question. Write down. Now, supposing the weight of A is 40 kilograms and the weight of B is 80 kilograms. Now, and you'll have to show that weight of A is half of the weight of B. Supposing you'll have to show this. Show that weight of A is half of the weight of B. So what you actually do is you will be working weight A by weight B is equal to 40 by 80. So weight A by weight B is equal to 1 by 2. 1 by 2. On cross multiplying, see, like when you have A by B is equal to 1 by 2. Don't we write A is equal to half of B? B, when you cross multiply, when you take B to the other side, it will be A is equal to half of B. When B is transposed, we get A is equal to half of B. Similarly, when you transpose weight B, you will get weight A, continuing with this, weight A is equal to half into this one, when you bring it to the other side, into weight of B. So half weight of B, half weight of B. It's given that weight A is 40 kgs, weight B is 80 kgs. They want you to get this weight of A is half of the weight of B. So how do you show this? Just divide one by the other. Weight A by weight B is equal to 40 by 80, 1 by 2. So weight A by weight B is 1 by 2. Upon cross multiplying, we get weight A is equal to half of weight B. This is what we have to prove. Prove that weight A is equal to half of weight B. Half of meaning multiplication. Weight A is equal to half of weight B. Similarly, here we have to prove that. We'll have to prove that or show that a red blood cell is half of a plant cell in size. You need to show that the size of a red blood cell. You need to show that the size of a red blood cell is half of the size of a plant cell. Size of a plant cell. This is what you'll have to prove. Size of a red blood cell is, see here, whatever is here, I've just written as an equation. Show that a red blood cell, that is the size of a red blood cell, is meaning equal to half 1 by 2 of into plant cell in size. So size of a plant cell. This is what we need to prove. So we need to show that size of a red blood cell by size of a plant cell is equal to 1 by 2. This is what we need to prove. So we need to prove that a red blood cell, that is the size of a red blood cell by the size of a plant cell is 1 by 2. Then on cross multiplying, you will get the size of a red blood cell is half of, when you take this here, half of a plant cell in size. That is why we begin like this. That's why we begin like this. Size of red blood cell by size of plant cell. Don't see the slide fully. Just follow what I'm trying to explain. Size of red blood cell by size of plant cell is equal to, this is the size of red blood cell given. This is the size of the plant cell given. Express, next step, expressed both in scientific notation or in the standard form. So this one, the decimal point is out here. 1, 2, 3, 4, 5, 6. It should come here. Only then it will become 7. The number will become 7. It has to move 6 places. It has to move. The decimal point has to jump 6 places or jump 6 times. Move 6 times. And it's a small number, 0.000. It's such a small number. It is, the whole number part was only 0. And you've made it 7. The whole number part was only 0. You made it 7. You've increased its value. So raise 10 to a negative power. So 7 into 10 to the power 6 jumps. So negative 6. Divided by 1, 2, 3, 4, 5 will do 5. So 1.275. 5 times. Negative because negative 5 because it was a small number and you've increased it. So you should raise it to a negative power. Please tell me if you understood till here, children. I'll just wait for a minute. You do the standard form for yourself. We need to begin like this and then write the numerator and denominator in the scientific notation or the standard form. Understood, children? Scientific notation?
Yes, ma'am.
Yes.
Okay. Next step, very good. Next step, don't disturb 7 and 1.275. See, 7 and 1.275. Don't disturb them. We have 10 to the power minus 6 divided by 10 to the power minus 5. Bases are same, 10. It's division because one is in the numerator, the other is in the denominator. So it's division. So we need to subtract the powers. So we have, you can see 7 and 1.275 in their own places. And then you can see the law being implemented, subtracting the powers. Minus 6 minus 5. Write both the powers and separated by a minus sign. So in the next step it becomes, minus 6 plus 5. Which becomes 10 to the power minus 1. Minus 6 plus 5 is minus 1. See if you understood till here. 1, 2, 3, 4, and 5 steps. Have you understood?
Yes, ma'am.
Yes,
Yes.
Okay. Now, see, now it's not that this is what you should do next, but when you look at this, what can be done next is that the power is negative here, 10 to the power minus 1. So you can bring it to the denominator. It becomes 10 to the power plus 1. From the numerator, if you bring it down to the denominator, the base will come as it is. Actually, you're writing the reciprocal of the base if you understand there. You're writing the equivalent because when you bring 10 from the numerator to the denominator, you're writing its reciprocal like 1 by 10. And the negative of the power minus 1 becomes plus 1. The same rule you're using. You're writing the equivalent. You're writing the equivalent. The base, when it comes from the numerator to the denominator, you're writing the reciprocal. Then you're changing the power, negative. You're going to write the negative of the power. So what I say is, when you bring 10 to the power minus 1 from the numerator to the denominator, 10 is 10. It's already become its reciprocal because it is the denominator, 1 by 10 it is. And minus 1 should become plus 1. Next, after this, slowly you should do it, So now next after this, what is 1.275 into 10? 12.75. You can see it here. This is nothing but 7 by 12.75. You can include that step. This is nothing but is equal to 7 by 12.75. No, I'm pausing so that I'm just giving you time to understand. Next, the idea is you want to shift this decimal point. You don't want this decimal point, 12.75. You don't want the decimal point. So you multiply and divide by 100. You multiply the numerator by 100. You multiply the denominator by 100. It's like extending it like this and writing. You're multiplying both the numerator and denominator by 100. So that's fine. It's like you're multiplying by 1. See, your 100 and 100 cancels. It's like you're multiplying by 1. So you can do that. Why by 100? Because we have to shift 2 places. We'll have to shift 2 places. And that can happen only when you multiply by 100. You can show it like this also. So after that, 7 into 100 is 700. 12.75 into 100 is 1,275. Now simplify, using the tables of whatever. Here it's 5. So divide by, simplify it, reduce it, bring it to the simplest form. And you'll see it as 28 by 51. 28 by 51. Now 28 by 51, children, you need not divide. You need not divide. Is 28 close to 25? We're just finding an approximate value. Is 28 close to 25? And am I audible and clear, children?
Yes.
Yes, ma'am.
Okay. And 51 is somewhat close to 50. And we know that 25 by 50 is 1 by 2. We want this value 1 by 2. Even if you divide, you'll get roughly, if you get 0.6 also, you must write 0.5. Let's divide 28 by 51. Divide, children. You divide in your book. Please divide and tell me. Don't use a calculator. Please divide and tell me. So not 250, no, sorry. 55.
Ma'am, it's coming like 0.5555.
No, I'm getting 0.54. 55, how did you get? See, let's divide it together.
Yes, ma'am. I have again multiplied it by 5, ma'am.
1. See, when we divide, it's 280. Sorry, 28 divided by 51. 28.0 it is. So we have to start. You have to take 280, so it will be 0.5 times 255. 25 is the remainder. You can add a 0. 4s are 204. And what is the remainder? 46 is the remainder. Add a 0. So now I think about 9 times. 9 times 459. 1 is the remainder. Like this, it goes on. We got 0.5. See, we want 1 by 2. That's all it is. Because approximately we got 0.5. That's what I've written here. 0.5. You can stop your division there. 0.5. So 28 by 51, when you divide, you get 0.5. Also, as I told you, 28 is close to 25. 50 is close to 50. 25 by 50 is 1 by 2. So like that, 0.5. Or 1 by 2 approximately. So now what did we get? We got that the size of a red blood cell. Size of a red blood cell is size of a red blood cell by size of plant cell. See, we started like that, no? Size of red blood cell by size of plant cell is equal to 1 by 2. We get is equal to 1 by 2. Now when you cross multiply, size of red blood cell is equal to half into size of plant cell. Is it understood, children?
Yes, ma'am.
Yes, ma'am.
All right. I think we have the same question in NCERT. I'm not sure because I picked questions from different books. Agarwal, I think this is in NCERT also. I'm not sure.
Ma'am, after exponents and powers, can you please teach us inverse and direct proportions?
Yeah, that was also requested by Devadarshini. Sure.
Yes, ma'am, because I have that chapter for my upcoming exam.
Okay, fine.
Ma'am,
Yeah.
ma'am, can you take comparing quantities after this chapter, ma'am? Because it's coming for 2 exams for me in maths, ma'am.
Which one in comparing quantities? Because there are many under that, no?
Ma'am, we have full chapter, ma'am, fully.
Oh, okay. So that means you have profit and loss, percentages.
Yes, ma'am. Discount, mark price, all, ma'am.
Compound interest.
Yes, ma'am. Simple interest, all we have, ma'am. Fully we have, ma'am.
Okay, fine.
Because we have for 2 exams, please can you take, ma'am?
Yeah. I need to prepare the material. This is the first year, no? So we are doing online. Otherwise, now next year it will be very fast because the material is ready. I can do any chapter anytime. The difficulty is that I don't have the PPTs. I have to prepare. Now, when you people say I have to prepare them, you understand what I'm saying?
Yes, ma'am.
Yeah. If it's a physical class, then anything can be done because I'm anyways going to work on the board. But in an online class like this, the material should be ready. And I don't get anything from the internet. I prepare it. So it's time consuming, but I should do it. I'm just telling you that I cannot do it like instantly. Like it'll take some time for me to prepare the material. Direct and inverse proportions is also a part of comparing quantities, right? Sindhu and Sanjay?
Ma'am?
No, direct and inverse variations.
No, ma'am.
Ma'am,
We have it totally. There are 2 different chapters, ma'am.
Come again, what?
They are two different
Ma'am,
chapters, ma'am.
Okay,
Yes,
okay,
ma'am.
doesn't come under that, is it? Okay. Which is excluded?
Ma'am, if you are not able to take the chapter, you can, if you send me if you have any videos, can you send, ma'am?
Videos on comparing quantities, no, I won't have.
Yes, ma'am.
Won't have, no.
Yes, ma'am.
Let me see, I'll try my best. We'll see what can be done.
Yes, ma'am.
Okay. Is this understood, children?
Yes, ma'am.
Yeah, please work this. Very mindfully work it. Don't just copy it like that. Every step as you write, understand what you're writing. You need to write it now, children. Don't take a screenshot. It's a very important question. Finish writing, children?
Yes, ma'am.
Okay, fine. Try this assignment, children. Take a screenshot. We'll see the answers in the next class. Please complete this assignment by the next class. There are 15 questions, or maybe by Saturday. By hurry. Tuesday, now it's Saturday, no? So next Saturday. Try to complete this assignment
ma'am.
next Saturday.
Yes, ma'am.
Yeah.
Yes,
Ma'am,
ma'am.
next class is on Tuesday, right? No, ma'am.
Correct. Yeah, yeah.
Okay,
Not
ma'am.
by the next class, by next Saturday. Yeah.
Yes, ma'am.
Yeah, please write down question number 10A. Please go through the answer first and then I'll explain. Please go through answer 10A. All right. So the first step is to break down 10. See, we have to simplify. We need to find the value of this expression. You can see there is 10 into 5 to the power n plus 1, 25 into 5 to the power n. These two are separated by a plus sign. Similarly, in the denominator, there is a product here, there's a product here, separated by a plus sign. You can even enclose this in a bracket. You can just put this in a bracket, see like this. Okay, first step, 10 is written as 2 into 5 and 5 to the power n plus 1 as it is. 25 is written as 5 squared and 5 to the power n as it is. Denominator, nothing much can be done here. With 3 into 5 to the power n plus 2, nothing can be done. Write it as it is. 10 is written as 2 into 5. Into 5 to the power n plus 1, which is there. Next step. Base are same, 5, 5. So we need to add the powers. So you can see this 2 down as it is. Base are same, add the power. So it will be 1 is the power here. So 5 to the power 1 plus n plus 1. And here also base are same. So add the powers 2 plus n. Denominator here nothing, write it as it is. Here base are same, 5, 5. Add the power. So the power is 1 here. Then on simplifying this, n plus 2. This is also n plus 2. This is n plus 2. And this is also n plus 2. Everywhere it is n plus 2. Now, every bracket has 5 to the power n plus 2. Every bracket has 5 to the power n plus 2. Bring it out common in the numerator and denominator. In the numerator, 5 to the power n plus 2 is common. So write it out. Now you can treat this as into 1. Into 1. So 5 to the power n plus 2 is common. This is common. It's written outside. So 2 plus 1. Here, 2 plus 1. Let me show you again. Into 1. 5 to the power n plus 2 is common. You can see this one outside. It's common. 2 plus 1. 5 to the power n plus 2 is common outside in the denominator. 3 plus 2. Write the remaining terms in the bracket. Now, how does that work? How does that work? See here, 2 into 5 to the power n plus 2 plus 1 into 5 to the power n plus 2. 3 into 5 to the power n plus 2. 2 into 5 to the power n plus 2. Now what happens? 5 to the power n plus 2 gets cancelled in the numerator and denominator. 2 plus 1, 3. 3 plus 2, 5. 3 by 5.
Understood, ma'am.
Very good. Okay. Wonderful. Please work it now. As you work, if you have any doubts, you can ask me. Please work the write down the question and work the answer now. Is it over, children?
Almost, ma'am. 2 more steps left.
Okay.
Completed, ma'am.
Okay.
Completed, ma'am.
All right, children.
Completed, ma'am.
Very good. All right. So as I told you, 10 should be written as 2 into 5, 25 as 5 squared, 10 as 2 into 5. Then wherever you can use the rule, base are same, add the powers, do it. So here you will have to add the powers, add the powers, add the powers, and nothing here. So that will bring you to this step. Every bracket you can see 5 to the power n plus 2 is common. So bring it out common, the numerator and denominator. This is out common. This is outside common. So in the bracket you must write 2 plus, there's nothing here, that means 1, 2 plus 1. 2 plus 1 in the bracket in the numerator, 3 plus 2 in the bracket in the denominator. So this gets cancelled and 3 by 5. Let's see the next one. So 16. You can see the question here. The question here. So 16 should be written as 2 to the power 4. This one as it is. 4 as 2 square. And this as it is. Denominator 16 you can see here. This is 2 to the power n plus 2. And the other one as it is. 2 into 2 to the power n plus 2 as it is. So you can use brackets. You can use the brackets. I've forgotten the brackets. You can put the brackets. All these, you can use brackets. So here you see that base are same, 2, 2, base are same, add the powers. That's what you see here. Here also base are same, add the powers. Bases are same, add the powers. Bases are same, add the powers. Then the next step is just simplifying them. Adding the powers and writing it. Now you can see that the powers are all different. The powers are all different. Which one to write? Which one to take out common? What is common? Which is common? You have n plus 2, you have n plus 3, you have n plus 6, you have n plus 5. Actually, anything can be taken out common. Okay, but we learn one of the methods. So of n plus 2, n plus 3, n plus 5, and n plus 6, we'll take n plus 2 common. So what we'll do, we'll take n plus 2 common in both the numerator and in the denominator. Whatever we see, we'll take the same thing common in the numerator and in the denominator. Now you will have a question, why only n plus 2, why not n plus 3? We can do with n plus 3 also, children. Let's learn one method first. So we'll take out n plus 2 common, 2 to the power n plus 2 common in the numerator and in the denominator. Now, this is a very important thing. How will you break down this? What is 2 to the power n plus 5, children? If you take out 2 to the power n plus 2, don't you think then it is into 2 cubed? 2 to the power n plus 5 can be written as, see, you have taken out from 2 to the power n plus 5. From 2 to the power n plus 5, you've taken out 2 to the power n plus 2 common. So from 2 to the power n plus 5, if 2 to the power n plus 2 is common, what is remaining? That's what we have to find. So into 2 to the power, 2 plus 3 is 5, right? 2 plus 3 is 5. So into 2 cube. Into 2 cube. Nothing when you multiply, you just try to multiply these two, you will get, try to multiply these two, you will get 2 to the power n plus 5. And for this term, 2 to the power n plus 2 is outside common. So into 1. Into 1. This into this will give you the first term minus this into this is the second term. In the denominator, 2 to the power n plus 2 is common. But there's n plus 6 here. So 2 plus 4 is 6. So 2 to the power 4. Because try to multiply these two. N plus 2 plus 4. N plus 6. When base are same and its multiplication, we add the powers. N plus 2 plus 4. N plus 6. This into this. 2 to the power n plus 2 into what is 2 to the power n plus 3? 2 to the power 1 because 2 plus 1 is 3. After you take 2 to the power n plus 2 common in the numerator and denominator, what should we write inside the bracket? But when you write the terms inside the bracket, when you multiply these two, you must get this first term. When you multiply these two, you must get the second term. When you multiply these two, you must get this first term. When you multiply these two, you must get the second term. So accordingly, you will have to give the powers. Now, when 2 to the power n plus 2 is common, you can also write 2 to the power 0 here. You can also write 2 to the power 0. You can also write 2 to the power 0 because 2 to the power n plus 2 into what will give you 2 to the power n plus 2 itself, 2 to the power 0. You can even, I've written 1, you can even write 2 to the power 0. So 2 to the power n plus 2 gets cancelled. 2 cubed is 8 minus 1 by 16 minus 2. 7 by 14 or 1 by 2. Is it somewhat understood, children?
Yes, ma'am.
Okay, we'll take a few more sums like this in the next class. It will become clear. It's completely new to you, so you might have some doubts here and there. That's okay. Just practice to the extent you have understood. When we work a few more sums like this, it will become clear. All right?
Yes, ma'am.
Yeah. Put a screenshot. Try to work the third one also, children. Try to work the third one, A, B, C. We finished A and B. Just try C by yourself. We'll also do it in the next class. All right, children. So that's it for today's session. Take the screenshot.
Yes, ma'am.
Okay. How many of us are there today? All of us? Okay, fine. I think Devadarshini is missing. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you,
Thank you,
children.
ma'am.
Good night, children.